Hi, first of all, thank you very much for having me here today, Raffaele. I've been participating to this event a couple of times before as a listener, and so it's a huge pleasure today to have the opportunity to introduce what we are doing in Aindo. I'm Daniele, CEO and co-founder of Aindo, indeed. We are an artificial intelligence startup of the International School for Advanced Studies, ISA, based in Italy, which is a PhD school on mathematics, physics, and neuroscience. It's very interesting to me also to be giving this speech after all this interesting presentation based on decision science and based on very nice algorithm and all of them talking of the possibility to take good and informative decision. And it's very nice because indeed what you grasp out of all these speeches is that now more and more all our decisions are based on data, on the possibility to having access to data. And in the previous speech, I got the fact that most of such applications are in the industrial field where availability of data is definitely not an issue. But when you try to translate these kind of opportunities and when you try to import these kind of techniques in fields such as medicines, healthcare, finance, and etc., other problems might arise in terms of switching the slide. I know. Okay. Yeah. No, too much. Thanks. And indeed, if you look at this graph, you will immediately understand what I'm talking about. Even though we now think that our AI is revolutionizing the world, and indeed is doing, the value that we extract from our data is far from being complete and full. In fact, almost 60–70% of the real data value currently is not explored. This means that we collect a huge amount of data, but the innovation raising from this type of data is definitely scaling at a different pace when compared to the amount of data we record. And to us, this can be definitely a challenge, and the reasons for this kind of problem may be addressed in several points. First of all, who works with data knows that training a model is the funny part. Training a model takes the 20% of the time. The rest is actually making your hand dirty with data. And data often may be geographically distributed. You might not have the real data in one single point. You have to collect your data from different data sources and import into your system prior to conducting the analysis that you aim at. On the other hand, sometimes there is another problem: data is not in the right format. For instance, we work a lot with the healthcare institutions, and at the end of the day, we realize that the data that you want to use is in a PDF. PDF contains, of course, the information that you would like to give to a model to train classifier, a regressor, or a deep learning model, whatever. Nevertheless, such type of information are not in the right structure to be immediately passed to the model. They need to be pre-processed. But the most pressing problem that we are facing, actually the most pressing, I've been taught to say challenge. The most pressing challenge that we face when dealing with data, it's nowadays privacy. GDPR regulation indeed is really constitute a real challenge to the usage, reusage, and availability and shareability of the data. And it's for this reason, actually, that I will introduce a concept. Might be, I don't know, when I started to discuss about this topic, which is synthetic data, about 3–4 years ago, I had very surprised faces. Nobody have heard of it. Recently, thanks also to the recent development in generative model and the wave of information that has been triggered by ChatGPT, actually generative model and its application bring a new wave of awareness. And indeed, synthetic data, it's a solution to privacy compliant data science. Indeed, what we do, if you look at standard approaches when dealing with data in healthcare, fintech, or other institutions, generally prior to having access to the data, you have to anonymize the data. Anonymization is a huge step nowadays in order to actually trigger collaborative projects between institutions, and also shareability within the same institution with different OE of the same institution might be complicated. And this is because you have to go towards many steps, many diligence steps or assessment, DPA, data privacy impact assessment, ethical usage of such type of data. And all this because at the end of the day, the data that you use are data coming from real people. If you imagine in the healthcare, you have patient data, clinical data. If you consider, I don't know, financial institution, you might have what people buy, how they use their credit cards over the year. And this kind of data, despite being very useful, at the end are sensitive because you might infer information that are private. For this reason, we decided to leverage technology actually generative models. In particular, we have a combined formulation of generative adversarial network named as GAN and variational autoencoders named as VI, that goes under the name of VI. Of course, now we are, like everybody else, also leveraging latest advances in transformer and included such type of things within our platform. But the idea of synthetic data is very easy to overcome all these problems that I've been discussing up to now. We have developed such a solution that, starting from your real data, trains a machine learning generative models, which upon training is capable of doing something very funny. It's capable of generating data that stem from the same distribution of the original data, but at the end of the day, they are artificial data. While stemming from the original distribution of the data, they come with the same statistical property and mathematical property of the original data. The model, what technically the model does, infer the joint distribution of the real data, and then once the distribution has been inferred, is capable of sampling new data coming from that distribution. In this way, the data are very useful because they keep the information basically untouched, but at the same time, while being artificial, they are void of any sensitive information. Therefore, they are, I don't like to use this word, but they are like fake data that mimic the behavior of the original data. This opens a series of possibilities when trying to push and try to foster AI adoption into the market, and overcomes critical patterns and critical challenges that nowadays are actually limiting a full adoption of AI. I've heard some concern in going full AI or being, of course, we are a big sponsor of AI adoption, and we, of course, are also a big sponsor of ethical usage of the data. And we find this solution to be a good trade-off in fostering innovation while keeping privacy and ethical usage of data still on point. Why I'm talking to this? Because, as I said, this is considered to be one of the revolutionary technology in the upcoming years. Indeed, Gartner forecast that by 2030, about 80% of AI model will be trained over synthetic data. This means that actually the majority of AI systems are going to be trained using fake data. It's also interesting because if we look backward at the rising of this type of technology, this first appearance at academia is about 2014. Then a popular use case was when Netflix was suited to use personal data because they, if I recall correctly, they used some kind of people data to feed a Kaggle challenge, and out of the challenge, people were able to re-identify the original user of the data. And since then, actually, a lot of effort has been developed in order to find, I would say, a solution in privacy enhancing technology that would be able to cope with the need of sharing and using more and more data, because at the end of the day, AI is cool, and as I said, is revolutionizing and will revolutionize even more our life. But there is this nice way of saying in AI, which is not data, no party. So at the end of the day, you have to find a way to reconcile artificial intelligence and innovation together with a correct usage of data. Actually, in 2022, we were able also to post to publish a first article on Enriched about our technology being applied to generate not only singular table, but actually relational databases. So we started with the idea of generating tables that at the end of the day can be shared because not personal anymore and can be used to train AI or perform business intelligence analysis, data documentation, and so on. And then over the course of about 2-3 years, we were able to extend the capability of our technology to being able to generate entire DB. So what we can do right now is creating clones of relational databases that at the end of the day can be shared without all those strings that would be attached to real data. What you can do at the end and why they are so interesting, because this definitely reduce cost and time of any innovation project, because at the end of the day, while you have to give access to the data, this is gonna take a long time collecting and storing, and every case has to be evaluated case by case. What we're doing recently is creating for companies which span from fintech to healthcare, synthetic data spaces in which the synthetic data can be shared much more freely among the network of software provider and so on. Definitely, this constitutes an improvement in data protection, in data privacy and protection, because if you look at previous anonymization techniques, anonymization is based on the principle of information destruction. What you do when anonymizing a data is you remove information. You remove information in a technique or in another in order to avoid common, I would say, attack to the anonymized data, in order to avoid that you can re-identify any real entity. But the process of eliminating information from the data comes at a price, the price of a utility. When you remove info, you decrease the utility of the data. And at the end of the day, that's not the only problem, because when you anonymize a data, the anonymized data, it's still a real data. If you have Mario Rossi and some kind of information about Mario Rossi, we can remove columns, but the anonymized record keep on being Mario Rossi. While in this case, when generating synthetic data, there is not possible to trace it back to the original entity, simply because the synthetic data does not exist in reality. So you cannot link it back to anybody really existing. And of course, this can be also used to take better decisions, because at the end of the day, the same technology that we use to generate the entire population of the data can be targeted to generate subgroups that are underrepresented with the real population. Let's have an example, fraud detection application. When you want to train an AI system on fraud detection, definitely, if you're lucky enough, I don't know in which sector you work, but if you're lucky enough, you don't have that many fraud. Otherwise, you should really look careful at your clientele. But on the same time, if you want to train a classifier on this kind of, on this data to better forecast frauds, you can use such type of technology and targeted generation, not to the entire population, but only on the fraud cases. Of course, this comes at some limitation. It's not like when you want to generate the entire population, nobody create information, that's for God. There has to be some signal in the data that you want to actually argument. Last but not least, how do we evaluate the generation? Once we actually generate the data, then we have still the task of confirming that the data that have been generated perform well on a variety of tasks, or indeed they perform well on the task you had in mind. We have developed API that evaluate the goodness of the data over 3 different dimensions. Of course, on privacy, we want those data. First thing, actually, this is a topic that spans more on regulatory issue. We have more regulatory problem than technological problem here. So the first thing that we look at is privacy. We try to conduct a series of privacy attacks to our data in order to ensure that none of the real entity can be re-identified when synthetic data are provided outside of our organization. Then we look at fidelity. Ideally, we want the data to be as useful as the original data, but this means everything and nothing. Being as useful means, okay, we want the synthetic data distribute, behave like the real data. This means that we conduct a bunch of analysis over the real data and the same type of analysis over the synthetic data. This could be marginal distribution, bivariate distribution, correlation, I don't know, whatever, feature importance, and so on. And then we measure the distance between the performances, the metrics that we are able to score over the real and over the synthetic. And if we did our job good, this means that the synthetic data actually mimic very well the real data. And even if I would give you fake data or artificial data to take informed decision, the decision that you will take using real data, synthetic data, would be the same decision that you would have using real data. Last but not least, this extend also over the possibility of using synthetic data to train AI. At the end of the day, nobody comes to us because they like synthetic data. Actually, they couldn't care less. They come to us because they want to share those data. They want to share those data maybe for artificial intelligence project. You want to train a classifier, you want to give this project to your data to a provider of, I don't know, a company that works in AI. So what you can do is, what we do in order to assess that this is doable indeed, we have developed a bunch of API, in particular in the utility that we call model compatibility. In particular, we train artificial intelligence model over the synthetic data. We train the same AI model over the real data, and then we measure the gap of performances in the model trained over synthetic and the model trained over real. And of course, we test on a left out set over the real data. To give you an idea, when it comes to privacy, if you use synthetic data instead of anonymization technique, you get very huge improvement, indeed, because the synthetic data do not exist. So if you are popular with the NVIDIA, this person does not exist web page in which you look at people, and every time the page is refreshed, you see an image of a person that indeed is very very similar to a real person, but do not exist. This is the same concept that we extended to tables. So that's why, because it makes very complicated to an attacker to re-identify anything in the real data. You can leak maybe something, but definitely less than you would do if you expose real data or anonymized data. When it comes to fidelity, and we'll go very quickly because I was informed to be very short. And when you go to look at fidelity, as I said, you measure a bunch of metrics over real data and synthetic data. Here I gave, for simplicity, just correlation and marginal, just correlation and marginal distributions. But we evaluate really a huge series of them. And indeed, you could look at any slice of the space of data. And if you performed the generation correctly, this should mimic the real data. And as I said, we measure the difference between these metrics and the metrics evaluated over the synthetic data. Last but not least, utility. As I said, we train a machine learning model over the real, a machine learning model over the synthetic. We evaluate the performances over a left out of the real data. And even here you see that the performances in terms of utility are all above 90%. In general, this is calculated over a very small table, but we have published a couple of articles in which we show performance are always above 90%. To conclude, what you can do with this, I will give you an example of an application that we have done recently. Imagine you are an insurance company and you have a fleet and you want to evaluate provider. She's like, I have to tell to everybody. That's why I run. And no. That's it. Okay, this is the last slide. Look, I promise. I was telling. Thank you. Imagine you are an insurance provider and you want to evaluate. You have a fleet of vehicle and you want to evaluate a provider of IoT, a platform, IoT platform to track this. I don't know, the data that come from the hub you install on your cars. Of course, in order to evaluate providers, you should give them. In order to evaluate their solution, you should provide the provider with the real data. But sharing data with somebody that at the end of the day, you don't even know if it's going to be one of your provider, it can be complicated and even useless. For this reason, we have been creating clone of the real data, of the real customer data, and the data that were shared were only the synthetic data. This, of course, as you can imagine, speeded up the process, reduced the risk, and at the end of the day, we're all happy. Thank you very much. I hope I was in the time.
Any question for Daniele?
Thank you. Thank you. I have a question about the privacy. So you use, for what I understand, you use data documentation techniques to generate synthetic data that stem from the same distribution, real one. Okay, good. So if I have your synthetic data, I also know the distribution, the model of real one, but the GDPR protect also the data by avoiding aggregation, so deriving model from real data. So I don't understand this point.
Okay. No, but I think you can hear me. Generally, this kind of system works on customer premises, meaning that the data controller already owns the rights to process those data, but doesn't own the rights to share this kind of data, usage or reuse the data, especially in the healthcare domain. If you want to reuse the data, this is something that even if you have granted the usage of the data for that specific application, this means that if you now want to use the data for another application, you cannot do it and you have to go back to the ethical committee and so on. This kind of a solution is once and for all. You synthesize the data, you have the consent to do it because it's at the level of an anonymization technique. Then what you came in output of the synthetic data generator is something that GDPR consider not personal data anymore. And at this point, you unlock the power of your data. Thanks.
Thank you, Daniele. An applause for him.